Good morning. My name is Jörg Schmitz. I'm working at Specim from Finland in Oulu. I'm responsible for business development. And I would like to show you some industrial insights for HSI applications. Some facts to STEMA Imaging. We are founded in 1995 in Finland, in Oulu. Our main business are spectrographs and industrial hyperspectral imaging cameras. We are 90 people in Oulu, or worldwide. We have a big growth, and we are part of Konica Minolta since 2020. And you see here our locations in Spain, in Barcelona, in Germany, Munich. I belong to Munich, and in US, New Jersey, and China, Shanghai. And then we have worldwide distributors. Our vision is to make spectral imaging easy. And perhaps you heard a lot of applications already, and it's a little bit tricky because you have a lot of data, 14-bit images, and so we have on our flag spectral imaging made easy. Why hyperspectral imaging? As usual in machine vision, we go beyond the visible. It's a non-destructive technology. It's a real-time inspection system. We have 100% inspection of the stream, close to 100% accuracy. Usually in machine vision, it's 90.8%. And we generate the chemical fingerprint. Chemical fingerprint. How can we compare it? What is hyperspectral imaging? I would like to show it in an example with an image. For example, we have a RGB image. And there we have 3 wavelengths, 3 planes, and it's like a small pamphlet, a small data sheet of a leaf, for example. Compared now with a hyperspectral imaging image, it is like a book. We have 220 planes, for example, and that means we have much more information of this leaf, a kind of chemical fingerprint, and it's like a book, it's like a manual of the leaf. And so you get much more information than with just RGB. So we have the broadest range of cameras for different applications and different wavelengths range. We start at 400 nanometers up to 7,700 nanometers in the long wave infrared, and we have different applications for the visible range. Mainly it's color, fruit, vegetable, skin, tissue, plants, film, water applications, NRR, sorting, mainly used in plastic sorting, for example, pharma, quality checks, NDS, shortwave infrared, minerals, environment, vegetation, art, safety. Then in the MWIR, it's black plastic. I come later to this topic. Surface, minerals, detection, oil, and then the long wave infrared for minerals, geology applications, security, ground and water temperature. But now I showed you a lot of information, but now images say more than words. How do we process these images? We have the Specim One spectral imaging platform because somebody has to process the images. And so we have a processing unit, it's the Specim Cube. We have the Insight, it's a graphical user interface. That means we acquire the data, create classification, apply the models to real time into an inline system on the cube. And so it's it's just clicking and no programming lines is needed. And we are compatible with MVTech Halcon, one of the biggest machine vision libraries with Beckhoff, NI, LabVIEW. And so it's easy to acquire and to process these images and classify the materials. But what can we do? Some images, some samples, that is the main interesting part of the presentation. Spectral imaging is grown up in plastic sorting. And Austria and Germany are world champions in plastic sorting or recycling. And so the main engine for spectral imaging is really, or the biggest business for spectral imaging is plastic sorting. And now we come to the dark side of plastic. A lot of people say, oh, we can't sort black plastic, let's burn it. That's not true. Since 2019, we offer the MWIR camera FX50, and with this camera, it's possible to sort black plastic and rubbers and non-black plastics and rubbers. And so I have to state here, it's possible to sort black plastic, and we do not have to burn this in the world. Here are some samples from black plastics acquired with the MWIR camera FX50. The illumination is a thermal illumination, and so it works inline in sorting applications. Here are some wavelength bands for the MWIR. Here you see different plastic types, and the higher the wavelength range, the better it is to sort. But now we come to the new applications that are not so common. And here we talk, for example, about applications in the new energy sector, solar cells. Everybody knows solar cells on the roof or on the wall, and you want to have a smooth or nice facade. And so there's a high color resolution inspection for photovoltaic facades or protection glasses. Here's the main aspect on aesthetics appearance. But there are, for example, new solar cells. They are so-called perovskite solar cells. And it's a multi-layer technology. And here it's possible to measure with hyperspectral imaging cameras the layer thickness of the different layers they put on these cells. Then another topic, new energy, fuel cells, bipolar plates, metallic bipolar plates. They are coated with a carbon layer, and the carbon layer is from 50 to 100 nanometers. Here we are talking about nanometers, not micrometers. And it's possible to measure the layer thickness of these carbon layers. And the other thing is the homogeneity of the layers. Here's a good address, Dive Imaging. They are here at the Trade Fair 2 in the opposite hall, booth 10, E70. And they can explain more about this technology, for example. Then other topic, not so new, but battery electrode coating, for example. Here it's possible to check the purity and the composition of materials, identifying, classify chemistries. For example, how they mixed the slurry. There you see a different behavior of the slurry. What are the binders, and how long did they mix it? Did they mix it too fast, too long, whatever? And there you make a golden template and to check the homogeneity of the coatings. And here you can ensure that you have the uniformity of the batches. Other application, web inspection, 100% inspection of coatings, film thickness, color, residual moisture. Here an example, for example, how stretched foil could look like on the right-hand side. Then pharmaceuticals inspection. Is the coating of the pills okay? Are the pills are the correct pills or the right pills packed? How is the concentration of ibuprofen or paracetamol, for example? Here you can differentiate between 200, 400, 600 and 800 paracetamol concentrations, for example. Then in the automotive, adhesives and glues. And here it depends on the background and the wavelength range and the behavior of the glue, whether it's dry or whether it's wet. It's comparable, for example, with electrolytes in the battery production. When they react or when they are in contact with the air, they change the chemical behavior. And so it's similar to glues. They change the chemical behavior too. And here it's possible to differentiate between or to detect wanted or unwanted glue, for example. It's not dirty laundry, it's textile sorting. And it's a law by the European Union that you have to sort textiles the next years. And so we are able to differentiate between different textiles. And it is done in automatic textile sorting for laundries, for example, another application compared to textile recycling applications. Then metal surface inspection. 100% inspection of metal, of burning or gluing, no, not gluing, burning surfaces. Check for impurities on steel. Or you have oiling machines before you bend metals. There you have to measure whether or what thickness has the oil, the water, the wax, or the lac on the film. And there you can measure it in micrometers or nanometers, the thickness of the oil. Sometimes you have to wash the metal and you want to detect whether you have rests of oil on the metal sheet. And that is possible to detect, for example, with the MWIR at 3.4 micrometers. That's another application. Then color, consumer optics, consumer products, display color inspection for smartphones or anti-fingerprint coatings. That is another application, for example, for consumer electronic to get the right color. Because don't forget, we belong to Konica Minolta. They grew up with color. Then further application, electronics, PCB inspection, coatings, layer thickness. Is it the right coating? Are there oxides or are there different mistakes or faults on the PCB? Here you see 4 images of or 5 images of different coatings. Here you see the layer thickness of each coating. That is, for example, possible in the NRR area. Then, short before lunchtime, some meat. And check your meat before you eat it. Here we extend the range of X-ray technology, for example, because X-ray is very well in detecting metals. But for us, it's like plastic sorting, because X-ray does not see plastics in meat or on meat. We can't look inside, but we can look on the surface. And so we can detect polyvinyl PET films, polyethylene, etc. And so there are a lot of applications in food for food safety. Then indoor farming, health check for plants. Are the plants happy? Because when you have a really big greenhouse and you have a disease in the greenhouse, then it can be sometimes very expensive. For example, when you hatch cannabis plants. And so there's always a healthy check for each plant, and that is done with hyperspectral imaging. And here you can check whether the plants are stressed, have too less water, and have they leaf spot diseases, etc. And that is done with hyperspectral imaging cameras. Then a practical example, when you go shopping, seal inspection for food packages. And here we check for, in the seal team, we check for paper, cheese, meat, mold, breading, humidity, fat. And because when the seal is not closed, then the air comes in and the meat will be not good. And it could be done, for example, for transdermal patches, nicotine patches. Perhaps you have seen them. There's a liquid inside. When the seal is not closed, then it's a problem. Then some cheese. OK, the video doesn't work. Perhaps it works now. Now it works. Here we have a cheese block, and we have some plastic films because they are of this size, and the robot unpacks the plastic, and sometimes they can stick some plastic, and when you then try to buy grated cheese, then you will have plastic in your cheese on your pizza, and that's not very convenient. So our cameras are made for robot applications. They are shockproof for 40 G, and they have a vibration test. And here you can see how the cameras are mounted, or the camera is mounted on this robot arm, for example, and check the cheese blocks. Food, new proteins. It's short before lunchtime, I'm sorry. But mealworms, for example, new protein source for us. And here we check, for example, the water content. Otherwise, there will be mold inside. Fat, butter, the most expensive thing when you buy a croissant. Protein content, chitin, that is the dirt of the mealworms. And that's, for example, possible with hyperspectral imaging. It's a measuring tool in this case. Now some fruits and vegetables for before lunch. And here, for example, for logistics applications, how fresh it comes in the warehouse, how fresh does it leave the warehouse, when to harvest, information for the farmers, color, appearance, brick value. You want to have sweet strawberries, for example. These are applications that are made for spectral imaging. And spectral imaging made easy. I hope I could have shown some applications, some interest, some new applications areas for you. Hyperspectral imaging unlocks new opportunities in the machine vision market. Even non-experts in spectroscopy can use our technology because it's just a graphical interface and it's just a camera, it's just an illumination. And SpecIm, we offer the complete range for high HSI cameras from 400 to 7,000 nanometers. And so, thank you very much for your time. And I would like to see you when you have questions at our booth. We are opposite here in this hall, just walk hereby. And when you have questions, you are welcome. We are looking forward to see you at our booth. Thank you very much.